All right. This is our 31st lesson on the study of the biblical flood, and Marion Fox, the author of the book, and we'll be looking at mechanism for ice deposition, the ice caps in Greenland and Antarctica specifically, those two places. And we'll be looking at the mechanism by which I have postulated or hypothesized that it occurred. I've argued that it was a planet that caused the flood, and God brought a planet close to the earth, and the planet then caused tidal flood. The flood was basically mostly tidal action. The planet first, most likely, according to the evidence that I see, approached the earth above the ecliptic plane. Now, we described the ecliptic plane in the prior lesson as an imaginary line from the center of the sun to the center of the earth. And that would be the ecliptic plane. And it come in above the ecliptic plane and deposited the ice in the northern hemisphere first, and after it revolved around the earth, and it deposited the ice on the continent of Antarctica. And so Antarctica was second, it wasn't first. Here's the designation of the ecliptic plane, what that means. And I will argue that the planet came in from above it, coming down at an angle, that it was above the ecliptic plane, and at creation, the planet Mercury was, and it came down. And I believe this was the planet Mercury. But we'll give the evidence for that later. So it come down on the first pass, it came down, and then it went out less than 1,000,000 miles, and it came back. It took about approximately 30 days, thereabouts, to go down and back around, and came back, and it did this 3 passes, and and each time the sun is pulling it up toward the ecliptic plane. By its gravity of the sun is pulling it. So each time it comes at a different angle. And then finally it comes, the last time, I believe the planet Venus aided the sun, and the planet Venus then helped to pull it away from the earth. At 1,000,000 miles from the earth to the sun, approximately, the gravity of the sun, the gravity of the earth are equal. And at that point, if you go beyond that point, this body that's revolving around the earth, it'll be pulled away by the sun. If it were, anytime it's closer than that, it will be retained as a satellite around the earth. Okay. So again, you have to get into the gravitational fields and how they operate. Okay. And they reduce exponentially with the distance. Okay. So I believe that's what happened here. Now, we'll show the evidence for that as we develop this further. The planet comes in above the ecliptic plane, and as it comes in, it has ice rings. These ice rings are pulled by the greater gravity of the earth toward the earth. Now, whenever the ice rings are on the opposite side of the planet, now again, I'm going to just say Mercury, I believe it was Mercury. When they're on the opposite side of it, the gravity of the earth would pull these rings toward the planet itself, because the gravity of the planet plus the gravity of the earth combined would pull it, and so it would pockmark parts of that planet. I believe in this case Mercury. Now, we'll come back later, but this is how I believe it happened. I'm convinced it happened. Okay. Any questions? Or evidence for this later. So ice was deposited in the northern hemisphere, coincident with the rain and fountains of the deep water from the oceans. And the word deep is almost universally used for oceans in the Bible, both the Old and the New Testaments. The southern hemisphere did not have ice until a day or so, or a few days after the flood began. So it had the flooding action before and it got the ice. We expect that some parts of the northern hemisphere will not have sedimentary rocks, but the southern hemisphere has sedimentary rocks. So that being the case, we would expect that some parts would not. They'd have been covered by ice that would not have melted during the flood because it was too cold. The symmetry of the ice caps about the magnetic poles of the Earth rather than the geographic poles of the Earth cannot be explained by uniformitarian assumptions. Snowfall depositing a few inches of ice each year, that's uniformitarian assumptions. Notice, remember, as we said early in this study, uniformitarianism has been rejected, yet they use uniformitarian arguments. They fall back on them over and over and over again. But they are uniformitarian in their arguments, most by and large. The flood model that I've advocated can easily explain this symmetry about the magnetic poles rather than geographic. Now, you'd think they'd be symmetrical about the geographic poles due to weather and the coldness, but they're not. So it's around the geographic poles. Cosmic ice would be extremely cold, near absolute zero, about approximately 459 degrees below zero Fahrenheit or 273 degrees below zero Celsius or centigrade. So it wouldn't be that cold, but it'd be pretty close to it. This ice, the floodwaters would not melt large amounts of the ice because ice would certainly be, some would be melted, but most would not because it's so cold. Cosmic ice can cause the rocks to fragment when they're wet from the tides and the ice hits the rocks. And so when it hits the rocks that are already wet, that freezes that water so quickly, and it'll fracture the rocks and fragment them, crack them, create gravel and other things real quickly out of it. Fragmentation. A tidal flood would bring in sediment, sand, and so forth that would mix with the fragmented rocks. And so this could easily happen, particularly in some places. As the ice melted and formed streams, either on top or under the ice, the flowing water would deposit this soil and rocks into eskers. So we'll see what those look like in a minute. The moving ice sheet, as the ice began to pile up, it would tend to slide toward the lower ground, lower locations, lower elevations. It would grind up rocks into layers that are called till. So the movement of that ice would do that. And I believe that moving ice does create this till. And here's a formation of eskers. We have water in here and ice, and then it flows out, and we get almost like a tube here, and it forms these eskers, and that's what they look like. Diagram. Here's a picture of some in northwest Manitoba, and we can see the eskers as they go along. Here's more in Wisconsin, eskers in Wisconsin. The cosmic ice that entered the atmosphere would cause condensation of the water vapor canopy and trigger the 4 days of rainfall. Remember, in order to get rain to occur, you have to have three things. You have to have sufficient moisture in the atmosphere, which we had a water vapor canopy that was sufficient moisture. And we have to drop the temperature, because as the temperature drops, the air can't hold as much water vapor. So the water vapor comes out in the form of rain. Another thing that would cause the water vapor to come out of the atmosphere would be a decrease in barometric pressure. So the higher the barometric pressure, the more water can be retained in the atmosphere. The lower the barometric pressure, the less water. So if we have a combination of a dropping barometric pressure and a dropping temperature, a colder temperature, we're going to have a lot of rain. And our situation is, once we begin to pull water out of the atmosphere, barometric pressure will drop. And the cold ice would trigger this and start this process. And this process would continue as long as this cold ice was coming through the atmosphere. and we had sufficient moisture in it to cause the rain. So this is the 40 days of rain was triggered by the combination of three factors: sufficient moisture in the air, a temperature that is lowering, and a barometric pressure that is lowering. All three of those together will cause rain. It's almost guaranteed to cause rain. Okay. The antediluvian barometric pressure was between 2 and 3 times the present barometric pressure. We'll show evidence of that later as we develop this. We'll show scientific evidence of it. The upper atmosphere had a layer, I believe, of water vapor. The water is above the firmament, and the temperature throughout the earth was fairly constant. We'll give evidence for that as well from the fossils and so forth. Now, here is your partial pressure of water vapor. And what we have here is we have a graph that shows the partial pressure. And this is saturation fraction of water in air at sea level. And as your temperature goes down, going from 40 degrees Celsius down to negative 60 Celsius, then now 37 degrees Celsius is human body temperature, about 98.6 degrees Fahrenheit. 37. Minus 40 Celsius is the same as minus 40 Fahrenheit. That's where the two systems meet. So that would be Celsius and Fahrenheit both. And minus 60 Celsius is pretty cotton picking cold. But right here, what we have is, as we cool it down, it holds less and less moisture. The air does. When it gets this cold down here, the air is virtually devoid of moisture. Moisture will come out of it. And that's a saturation fraction of water in air at sea level. And that's the same barometric pressure. Again, of course, if you raise the barometric pressure, this graph will change because of increased barometric pressure. This is a graph for a standard barometric pressure, okay, at sea level. Now, water vapor pressure, this is the vapor pressure. Now, this shows how the vapor pressure also affects it. So if we change the pressure, we get a graph similar to it, similar to the last graph, similar to this one. All right. Again, now we see the relationship between barometric pressure and temperature both, as they affect the amount of moisture that can be in the air, water vapor pressure. Here's another graph of it. This is in inches of mercury or torrs. Not inches of mercury, but torrs. That's a metric unit. The entry of cosmic ice into the upper atmosphere lowered the temperature of the water vapor. So it lowered the temperature. Lower temperature caused rainfall. The rainfall lowered the barometric pressure. The lower barometric pressure caused more rainfall, continuing the process for 40 days until the atmosphere was pretty well lost that canopy completely, lost it forever. Water vapor, however, we do have a problem. And I read a book or two by someone who wrote that they were convinced that the Bible was wrong and they became atheists because of their misunderstanding of this regarding the flood. Because water vapor releases energy at the following rates when it changes to liquid water. This is known in physics and chemistry. We release 540 kilocalories per kilogram and 540 kilocalories per kilogram, or 260 kilojoules per kilogram. And again, 2,260 kilojoules per kilogram. And we release 970 British thermal units per pound. All right, a British thermal unit basically is this. It will, when you take a pound of water, it will heat it up. British BTU will heat up a pound of water 1 degree Fahrenheit. The other systems of 540 kilocalories per kilogram, basically a kilocalorie will heat up. It takes 540 kilocalories to heat up a kilogram of water by 1 degree Celsius. Basically, that's what they're saying. Kilojoules also work that same way. So it's measuring how much you can heat the water up. In addition, 1 BTU, British thermal unit of energy, to a pound of water would raise the temperature of the water by 1 degree Fahrenheit. The other units would raise it 1 degree Celsius for that amount of information. With 33.9 feet, that would be 10.33 meters of water falling on every square inch of the surface of the Earth. It would be 14,259 BTUs per inch of energy, square inch, released by the water vapor changing to liquid water. That's a lot of heat. 33.9 feet or 10.33 meters of water falling would reduce the atmospheric pressure by 50% from 2 atmospheres, 29.4 pounds per square inch, or 2.026 times 10 to the fifth. That'd be 202,600 pascals to 1 atmosphere. 14 pounds per square inch, or 1.013 times 10 to the fifth pascals. Okay, Pascal is a metric unit. This release of energy would have been over a period of 40 days of the rainfall. Now we have a problem here with this release of energy because the release of energy would just get things too hot, kill everybody in the ark even. Some mechanism must have absorbed this energy, vast amounts of energy, had to absorb it. The amount of heat would have killed everything on the ark unless it was absorbed by some mechanism. Again, God didn't rule that, determine that to be to happen. 1 BTU is a quantity of heat that must be supplied to 1 pound of water to raise temperature to 1 degree Fahrenheit. 1 kilogram calorie is a quantity of heat that must be supplied to 1 kilogram of water to raise the temperature to 1 degree Celsius, 1 Celsius degree. The problem, however, we have too much heat. We're going to kill everybody, even the fish in the ocean. The problem is solved with the position that there was cosmic ice in the polar region simultaneously with the rainfall. This would lower the temperature and offset any heating effect from the condensation. That's my argument here. The following slide will set forth mathematical proof of this claim, of my claim that this was the case. From the fundamental heat equation, H equals WC delta T, this English units, or H equals MC delta T, standard and SI units, is determined that cosmic ice temperature of minus 273 degrees Celsius, or approximately minus 459 degrees Fahrenheit, would require 246 BTU per pound, or 136.5 kilocalories per kilogram, or 591.3 kilojoules per kilogram to raise the ice temperature to 30 degrees Fahrenheit. That's the point of where it would melt. It takes a lot of heat to do that. That's the latent heat of fusion of water is 144 BTU per pound, which is 335 kilojoules per kilogram, or 80 kilocalories per kilogram. It would require this additional amount of energy to melt the ice. The latent heat of fusion of water is the amount of energy that would be required to melt 32 degrees Fahrenheit, 0 degrees Celsius water, pure water, of course, H2O. Well, H2O weighs 8.33 pounds per kilogram per gallon at 37 degrees Fahrenheit. It would require about 2 pounds of cosmic ice to absorb all the heat released by 1 pound of water vapor condensing, assuming a constant pressure, of course. Other factors would absorb much of the heat as well. Clouds and ice would raise the albedo of the Earth. Now we have to talk about what albedo is. It would raise the albedo of the Earth, and so we'd have that raised. The present average albedo. Now, what is albedo? Albedo is the reflectivity. Let me illustrate this. If we have half of the energy from the sun reflected back out into space, albedo is 0.5. And the average albedo is 0.31, which means 31% of the energy is reflected back into space, 31% of the energy. The albedo of clouds, however, is 0.78, or 78% of it gets reflected back if we have cloud cover. That's why it gets cooler when we have cloud cover. Light, the energy cannot get through and heat us. The albedo of the Earth was changed from 0.31 to 0.78 during the flood while it was raining. This would also tend to cool the Earth off. Now, white ice has a very high albedo, so the ice caps would reflect the heat back out into space. And so that would effectively cool things down. Now, fluctuation in ice temperature during the ice ages. Now, again, the term ice ages is used by the atheist and old earth creationist. But what I'm saying is there were no ice ages. There was ice falling during the flood. The excitement began last September, this is a quote, when a team of researchers drilling into the Greenland ice sheet reported that oxygen isotope measurements from the cores showed that air temperatures during the period from 8,000 to 40,000 years ago, again, they're dating as uniformitarian-based arguments, has fluctuated widely. So the air temperature just fluctuated back and forth widely. We're going to explain how this happened and why it happened. Of course, the atheists and the old earth creationists have no explanation for this occurring. This is why it excited them. A second team drilling in Greenland confirmed that observation in February and showed that the large oscillations in temperature had sometimes occurred over decades. Now, remember, when they see 10 layers of ice, they consider that decades. And so they get the layers of ice and they interpret this to be years, each layer for a year, like a tree rings. So the ice chronology. Again, they've made assumptions about what these layers represent. More precise measurement reported in July showed that these oscillations occurred over an entire ice age. So it went back and forth, these changing every few thousand years from glacial to relatively warmer periods, according to MacDonald. Again, they're assuming this ice took thousands and thousands of years to deposit, which I don't believe it did. Now, let's go to how we can explain this with a reasonable flood model. What we have here is in Genesis 8:1, and God remembered Noah and all the beasts and all the cattle that were with him in the ark, and God made a wind to pass over the earth, and the waters assuaged. So there was a wind that passed over the earth as well. And kind of keep this in mind. There were two sources for winds. And one is that colder air is more dense and it flows and moves under as it goes down the slope or down a hill, and it moves under the warmer air. The warmer air is pushed up. And also we get winds from tidal action. The tides of the moon causes a wind current of about 1/20th of a mile per hour at this stage. At the distance the Earth is from the moon, about 250,000 miles away. So during this time, I would argue that both mechanisms were occurring, causing winds during that time. The cold air and also the tidal action would cause high winds. The fountains also that even under heaven were stopped, and the rain from heaven was restrained. And the waters returned from the earth continually. They were returning, and after the end of the 150 days, the waters decreased. So they didn't decrease until 150 days. So that's according to the text of the Bible. But my point here is we had a wind occurring, and this wind would blow the warm and cold air around and make this temperature go up and down of these isotopes, different isotopes. What do we mean by isotope? We've talked about this before. We'll come back to it again. But an isotope is a isos is the Greek word for same. it's the same element, but it has a different number of neutrons in the nucleus. Now, the number of protons in the nucleus determines what element it is. But if you take your various isotopes, you can have more than the standard value of neutrons in the nucleus. It's likely that the winds that occurred during the flood mixed warm air with the ice coming through the windows of heaven. And so we'd have the flow of warm air and then cold air and then warm air and cold air back and forth over a period of maybe just a few hours rather than years or decades, as they argued. It's almost certain that ice also continued to rain down outside the polar regions as the planet approached the Earth. So we have it raining down in other locations. No doubt the ice floated from the polar regions into the oceans during the flood. So we have a very cold ice floating in the polar regions into the oceans. Emmanuel et al. Theorized that a bolide struck the Earth. Bolide bolades is a Greek word, which means something thrown. A bolide is a term used for an object like a comet or a large meteorite that would hit the Earth, or an asteroid or something like that. So they theorized that a bolide struck the Earth somewhere in the ocean and set up super hurricanes. They call them hypercanes. So super hurricanes were set up. And of course, the bolide would be hot as it come in. But if the bolide happened to be a chunk of ice, it'd be cold. So again, we have a number of factors here that can offset this heating effect of the water falling. Another source of winds during the flood, of course, is tidal forces. According to Defant, moon tide causes tides in the atmosphere of the Earth, which have winds of about 1/20th mile per hour. Defant pages 106 to 110. This helps the Earth atmosphere to mix and keep it where the oxygen and other gases are kept mixed and churned. If the planet that caused the flood had the mass of Mercury, which my hypothesis is that it was Mercury, and came within 15,000 miles of the Earth, it would cause atmospheric tides several thousand times the present 1/20th mile per hour, in excess of 150 miles per hour. So we'd have winds 150 miles per hour or greater during that action when it came that close to the Earth. These atmospheric tides would tend to rotate as the ocean tides rotate. Now, a tide moves in a circular rotation. Tides are caused not by gravity, but by a difference in gravity. It's because the Earth is spherical, then the distance from the moon to the Earth is different at different points on the Earth's surface. The differences in those tidal forces and the gravitational forces create the tides and cause them to occur. But we won't go further into that. All right. Cosmic ice might be another source of the wind which passes over the Earth as the water sways, according to Genesis 8:1. Winds are usually caused by a difference in temperature as the heavier cold air rushes under the lighter warm air. Again, this is my claim that this would occur. The colder air in the Arctic and the polar regions would rush toward the equator and also help to change the climate. So we have a change in the climate because of that. These winds were cyclonic, rotating in a circular operation in nature, corresponding with the rotating tide. They produce regions of the surface of the Earth that geologists call basins. Heading waters, whether caused by high waters, tidal forces, or both, would produce areas with diminished deposition of sediment as well. Those rotating waters would act like a giant centrifuge, which would deposit the sediment in a somewhat circular manner outward from the center of the circle. This would separate the various minerals according to their density. I remember as a boy we didn't have electricity, and so I had to crank a centrifuge, basically, separated the cream from the milk. Cream is lighter than the rest of the milk. So when you spin it, the cream would come out of the top, out of a funnel at the top, or a nozzle out of the top of it, like a spigot. So the minerals having different weights, different densities, would tend to move and deposit themselves in veins or layers in the sedimentary rock. That's why we get veins of gold and silver and other copper and other things. Another effect of these winds would be to dry out the land that was exposed, to dry it out very quickly, particularly after the rain had stopped and the air was fairly dry. Winds caused by tidal effects would tend to dry out the surface of the earth that was exposed. Remember, the tidal flood water would go out and come back in, go out and come back in. So we'd have that. If the waters of the flood were tidal in nature, there would be times during the flood that the waters would flow off the land, and some part of the land would be exposed. During these times, these winds would dry out the exposed surfaces of the earth. So we'd have an exposure, places would be dry and look like a desert as far as the rocks. First, these high winds would cause extensive wind erosion on the parts of the land that were exposed. Very high winds will blow the soil around, particularly if it doesn't have a covering on it, like vegetation. This wind erosion would produce sand dunes and other desert-like regions. So it would produce that. These regions would then be covered with sedimentary rock during the next high tide. So we would have desert-like region that covered up with more sedimentary rock, and it would make any of the assumptions of the atheist who's not believed in the flood. He would have assumptions about what had happened in the past, and his assumptions would be based upon erroneous information. He'd have the wrong conclusions. If mud was on the surface, it would dry out and crack and then be filled with sediment during the next overflowing of waters. So we get what we call mudstones to occur. That would occur too. Mud was formed from the rain during the 40 days rainfall. It might not have marine fossils in it. Might not. It might. On the other hand, mud cracks were formed by the winds during the flood. We're going to argue that. Sand dunes were caused by the winds during the flood as well. We're going to argue that. Furthermore, ripple marks were formed in the stones, formed before the stones solidified. Ripples of water. Here's some mud cracks of soil, and you go out. I know as a boy, we'd get a rain, and then the winds would come, the dry winds, and we'd see these little mud cracks all over the place. This is just some ground where it's cracked due to the change in loss of the water, and the material shrinks and forms cracks between them. Here's some more mud cracks. These are actually stones now. When we get it, this mud is dried out, and then either sediment fills the cracks or wind-blown soil fills the cracks. That can happen. Next, the mud is formed into solid rock. After we lay some groundwork, we'll show that the Fox flood model readily explains mud-cracked rocks, mud cracks, mudstones. Here's a picture of some mud cracks in rock in Arizona, and you can see it there. And here's another one in the state of Maryland, mud cracks. And here's some ripple marks in rock, the ripple marks. And again, the winds blowing the water would form ripples. In general, mud cracks may be considered one of the best evidence for non-marine deposition. Well, that's okay. In some formations, however, mud crack layers are interbedded with others bearing marine fossils. So they say they're interbedded. There's marine fossils, and then there's a layer of mud cracks and back and forth. Well, my model would explain this. Typical mud cracks occur rather common also in some of the impure layers of the lower Ordovician and limestones of the Appalachian Trough. Now notice, there is no evidence here of non-marine deposition. And the mud cracks seem to have formed on a very shallow seafloor that was subject to intermittent exposure over considerable areas of at least a few months at a time. The nearest approach to a comparable environment in the modern world would be the Rand of Kutch, east of the Indus Delta, And there's some 8,000 square miles lying within the belt of monsoon rains. So this occurs during half of each year when the winds are blowing onshore. It's a very shallow lagoon. But during the dry season, the strong offshore winds drive the seawater out, leaving its floor exposed to be extensively mud-cracked. It does suggest the possibility that persistent winds may at times have driven the water out of very shallow parts of some epieric. Epieric is the word upon the land, seas that go upon land. So as to expose considerable areas of the bottom long enough to permit mud cracks to form. Dunbar and Rogers. Well, again, my model will explain this. Here's a man of Kutch. And so we have this in this Gulf of Kutch, Gulf of, I can't even pronounce the word there. Here's a picture of this. This is the Arabian Sea, Pakistan, and of course this is India over here. So we have Pakistan and India in this region right in here. Okay, so this is in India, but this is Pakistan over here. Okay. Mudstone must be deposited rapidly and covered with other sediment rapidly in order to survive as mudstone. Now, the reason that that's the case is because mudstone contains large amounts of organic material. In aquatic environments, that's organisms that bore into the sediment, tend to eat the organic matter. In sediments, and mudstone must be covered with layers of sediment so deep that these organisms cannot extract the organic matter. In other words, if it's not covered quickly, then the organisms that bore into and eat this organic matter and feed on it would have gotten most of it, depleted all of it. There wouldn't be mudstone. It would not have the layers. The mud has to have organic matter in it to be mud. So they just cannot do it. The animals would eat it. If the mud is dried and stays above water levels for extended periods of time, earthworms or other similar animals will extract the organic matter from the mud. So this is animals that are above ground, they would do it. And aquatic animals would do it if it stayed under the water, or marine animals if it stayed under the ocean. Without this organic matter, the sediment will not become mudstone. It's not mudstone. It has to have organic matter. A tidal flood with high winds at low tide would explain the formation of mudstones. High winds would also be devastating to forests by uprooting trees and breaking trees. That certainly could occur. There's evidence that many trees were broken during the flood. Many of the trees found have been stumps on the tops of the tree having been broken off. So that's a possibility. That's me several years ago, and I was in England, and here's a tree. I'm not arguing that these trees were caused by the flood, these broken trees, but there's some broken tree stumps sticking out of the ground. They're broken. These may have been caused by the flood, but they may not. This I'm not certain. I have not studied this fully to know whether this was or was not. I was there in the wintertime in England. This is in England. Okay. The pile of broken tree stumps. I climbed up on top of it a bit, get a picture of me on it. These broken tree stumps in a bog in England were broken off at or near ground level. They're broken off at or near ground level. This region, I think, was probably covered with ice soon after the trees were broken. And these trees fit a tidal flood model, possibly tidal winds that broke the trees at ground level. High winds, 150 mile per hour winds would do it, definitely break trees off at the ground level. Tidal flood would not necessarily cover all the land on the first day of the flood. As the tides rose, more animals were drowned by the waters. The winds dried out the surface of the earth that was exposed. Animal tracks were preserved in the sediment. Again, we have animal tracks in the sedimentary rock. These tracks were covered by the next tide and preserved as fossil footprints in the rocks. So we're going to stop there and end it with this. Now, I have a question here. Does anyone have questions of me regarding this material? We'll stop on that at this point.